A large pool of adults earning their first driver's license includes 50% low-risk drivers, 30% moderate-risk drivers, and 20% high-risk drivers. Because these drivers have no prior driving record, an insurance company considers each driver to be randomly selected from the pool. This month, the insurance company writes 4 new policies. Uh, Calculate the probability that these 4 will contain at least 2 more high-risk drivers than low-risk drivers. Now, this is a trinomial distribution, which is a special case of the multinomial distribution. Now, multinomial distribution is less frequently studied than the binomial distribution, so let's talk a little bit about it. The formula for the probability mass function is given as n factorial over x1 factorial times up to xk factorial times p1 power x1 times so on up to pk power xk, where n is the number of trials like we have in the binomial distribution. It's the same thing. So here we have more than 2 outcomes, more than 2 possible outcomes. So let's say there are k possible outcomes. So x1 is the number of instances of event 1, and so on, and xk is the number of instances of event k, and the corresponding probabilities of the k instances are p1 through pk. So for a trinomial distribution, we will have x1, x2, x3 over here, and more conveniently, we can also use x, y, z instead of x1, x2, x3. So, and in this case, n is 4, because we are writing 4 new policies, and we are trying to see what happens in those 4 new policies. So n is 4 here. So this formula will, if we let x to be the number of low risk drivers, y medium risk drivers, and z is the number of high risk drivers, and the formula will become xyz, f of xyz, and for simplicity, we can just omit this n and these p's, which is something which we also do in binomial and Poisson frequently. We don't normally write the n's and the p's, we just write the x's. And so this will then become f of xyz equals n factorial, so n is 4, as we said before, over the x factorial, y factorial, z factorial. Normally we said we had x1 factorial, x2 factorial, x3 factorial, and the probabilities of the 3 types are 0.5, 0.3, and 0.2. So it would be 0.5 power x, 0.3 power y, 0.2 power z. Now we need to find the probability that we have at least 2 more high-risk drivers than low-risk drivers. So remember that high-risk drivers were z and low-risk drivers were x. So we want the probability that z is at least as big as x plus 2, at least 2 more high-risk drivers than low-risk drivers. Now, also, we need to have x plus y plus z is equal to 4, because 4 is the total number of trials, and some of them will be x's, some of them will be y's, some of them will be z's. So combining these 2 conditions, that we need x plus y plus z equals to 4, and also we need z to be bigger than equal to x plus 2. So all the possible values that satisfy these conditions are listed here. So you see when x is 0 and y is 0, z has to be 4, because the 3 have to add to 4. And in this case, we do have z to be bigger than or equal to x plus 2. When x is 0, y is 1, z has to be 3 because they have to add to 4. And in this case also, z is bigger than or equal to x plus 2. In fact, the difference is 3. In this case, the difference was 4. So we need the difference to be at least, the difference between z and x to be at least 2. So when x is 0, y is 2, then z is forced to be 2, and still the difference of z and x is at least 2. And then these are the all possible situations where x could be 0. And next we have x is 1 and y is 0, and then z has to be 3. So z is at least 2 bigger than x. And there are no other values for which z is at least 2 bigger than x, and the values are adding up to 4. So these are the 4 possible cases. And so in the first case, x is 0, y is 0, z is 4. So 0 factorial, 0 factorial, these are both 1s, so z is 4, so that's 4 factorial, which cancels out with this. And x was 0, so this is 1, y was 0, so this is 1, and z is 4, so we'll have 0.2 power 4, which ends up being 0.0016. And similarly, when we do the other values for x, y, z, we get these values. And the required probability of z bigger than or equal to x plus 2 will be the sum of all the possible cases in which it can occur. And when we add up these 4, we get 0.0488, which rounds to 0.049, which is choice D.